Alright, let's look at the homework 2.7, problem number 3. Alright, so again, we have a displacement function given, s equals t squared minus 9t plus 16. Alright, then we want to find the average velocity. Alright, so average velocity is just the difference quotient, right? So like the slope of the secant line. So I'm going to just do that, and I'm going to actually cheat here. So I'm going to just type in, let's see, s of t is equal to t squared minus 9t plus 16. Right? So this is a function, and then plugged in. Right? So if you want to find average velocity from t equals 3 to t equals 4, so that's part 1. So let's find out. So that will be s of 4 minus s of 3 and divide by 4 minus 3, which is going to be 1 anyway, but just type it in. Right, so that came out to be negative 2, so I put negative 2. Right, and 3.5 to 3.4, 3.5 to 4, so that would be the same thing, except that you're going to put s of 4 minus s of 3.5, and the difference is going to be 0.5, so 4 minus 3.5. Right, so it's going to be negative 1.5. Alright, so next one is from 4 to 5, so we're going to put s of 5 minus s of 4. Then the difference is again 1, so but I'm just going to put 5 minus 1. So it's going to actually give you 0. Alright, and the last one is s of 4.5 minus s of 4 and divided by 4.5 minus 5, which is going to be 0.5. Right, so it's a 0.5. Alright, so we got those. And find the instantaneous velocity at when t equals 4. Alright, so let's do that. Alright, so we're going to have to take the find the slope of the tangent line at t equals 4. So we need to find s prime of 4, which can be found by limit as h approaches 0. Then you have, let's see, s of 4 plus h minus s of 4 divided by h. Right? Then if you use this function and plug in 4 plus h, so we have a limit as h approaches 0. Alright, so 4 plus h squared, I'm going to go ahead and square it. So it's 4 squared would be 16 plus 2 times 4 times h, so it's 8h, and plus h squared. Right, minus 9 times 4 plus h, so I'm going to just go ahead, 9 times 4, 36, and negative 9 times h is negative 9h. Right, then you have plus 16, so plus 16. Alright, then you have to subtract s of 4. So let's see, so 4 squared would be 16, and 9 times 4 is negative 36, and plus 16. Right, then all over h. Right, then you can cancel 16 minus 16 and negative 36 minus negative 36, and the 16 minus 16, right? So we have that. Then we have, just need to simplify a little bit, so we have a limit as h approaches 0. Alright, so we have 8h and minus 9h, so that will give us negative h, and the only other term would be h squared, so that would be h squared there divided by h. Right, then we factor out the h from the top, so we still need to evaluate limit as h approaches 0. H is factored out, so you have a h minus 1 over h. Right, then we can cancel h and h. Right, as h approaches 0, so this is going to be negative 1, because this guy goes to 0. Right, so the instantaneous velocity at t equals 4 is negative 1. Right, so oops, let's plug in negative 1. Alright, so let's double check and go here, submit for testing. Alright, looks like we got everything but that one. Maybe I messed it up typing in. Let's still redo that one. Alright, so I'm gonna go here. Alright, so I don't know what I did wrong, but I'm gonna try again. So you have s of 4.5, maybe I mistyped things, s of 4, and divided by, and 4.5 minus 4. Alright, so let's double check. Oh, it was negative, so maybe a negative sign was off. Alright, so we have that. Alright, so let's check again. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.